Okay, look here. I'll just explain this part again. The equation is given. You are told to find the coordinates of the stationary point. By the meaning of stationary point, you know the gradient is equal to 0. Do your first derivative. dy dx is equal to 0. Equate to 0 and factorize to solve. And I say again, you do not need to show me how to calculate the respective value of y. Straight away, get the value of the x coordinate, substitute inside the original equation to get the value of y. After that, please write out what are your stationary points. Okay, up to here, any question? Now, moving on, this is the part that is new. You need to determine what point is this. Meaning, is it going to be a maximum point? Is it going to be a minimum point or a point of inflection? Likewise for the second one. I'll do the first one for you first. We always take a look at x. What is the value of x over here? 3. You need to choose a value slightly smaller than 3. You need to choose another value slightly bigger than 3. So in this case, we always say this is 3 minus, this is 3 plus. Slightly smaller. What do you think is a good value that is slightly smaller? 2.9 is good enough. Only 2.99 or 2.9. What is the value that is slightly bigger than 3? Remember, don't choose by 0.5. The difference is 0.1 is good enough. Now, this is the value of x. We need to make use of the gradient. That is why I do the explanation just now. Increasing, increasing, then we find inflection. If it's increasing, decreasing, it could be a maximum point. Let's look here. dy dx. No brainer. 3. Number 3, if you put it inside here, what do you think your dy dx will be? 0. This is where it comes from. At point number 3, x is equal to 3. Confirm the gradient is equal to 0. Now, same thing with the use of a calculator. You are going to use 2.9, put it inside here. 2.9, put it inside here and press the calculator. Will you get a positive or negative value? Can you do that for me now, everybody? Everybody, everybody, don't copy. Positive or negative? Anyone got positive? We just need to conclude positive or negative. We don't need the exact value. Positive or negative? Negative, so I write down negative. Similarly, 3.1. Plug it inside here. Do you get positive or negative? Positive, Yeah. Confirm? Yes. Because I must tell you, if these two are wrong, your whole question will be wrong from this part onwards. If these two are right, everything is going to be correct with you. Now, if the gradient is negative, am I right? It should look like this. So we are looking at the shape now. If the gradient is 0, horizontal straight line. If your gradient is positive, going upwards, right? So now, I'm going to join all these together. What shape do we have? Smiley face. What kind of stationary point do we have? Minimum point. So, 3, negative 22 is a minimum point. That's it. Box method. The box method, I say again, you need to make use of the exact value of the x coordinate, choose a smaller and bigger number, find out how will the gradient look like. Based on the gradient, look at the shape. After that, determine the shape and conclude what kind of stationary point do you have. Question so far? If there's no question, I'm going to give you 3 minutes. You construct exactly the same kind of table for the second point. Yes. Not necessary. Good. Good analysis, Andy is saying, yeah, first point minimum, second point confirm maximum, not necessary. But you cannot have two minimum. You can have a minimum and a point of inflection, a maximum and a point of inflection. Andy? So you need to find out, you cannot just conclude this way. Okay, remember the gradient, you only need to tell me whether it's positive or negative. You don't have to give me the exact value. Quick check, Jia Kai, this one. This one. So this one, the shape will be going up, horizontal. So what kind of shape do we have? N shape. If this is the N shape, what kind of stationary point are we looking at? Maximum. So we conclude -110 is a maximum point. Then comes the last part, very interesting. Sketch the curve. Do you think it's very difficult to sketch the curve? On first glance, Mr. Liu, we never learned how to sketch the cubic equation. I agree. Okay, this is cubic. Never learned before. We only learn quadratic. But this is precisely why we need to make use of these two information. We need to locate the point. I'm going to do it now. You'll do likewise for the next one later. You need to plot the points. First thing, 3, -22. Okay, I'll estimate roughly. 3, -22. This is where you have your minimum point. Agree? Next, -110. What will you have over here? Maximum point. This is the maximum point, this is the minimum point. What other things can I find inside this so that I can plot easily? Anyone? Suggestion? These 2 points cannot do anything one. At most I can do this. Oh, Mr. Liu, this is the minimum point. I can straight away like this. Yes? Melissa, I heard it. Thank you. Where does it cut the x and y? Remember your curve sketching, what are always the first 2 steps? The x and y intercept. X-axis make y is equal to 0. When y is equal to 0, are you going to solve? Don't need. Press the calculator. You will get 3 answers. Ashwa, can you help me press? Solve for cubic equation. Decimal.
Negative 2.180. Second one is 4.69. Third one is 0.488.
Okay? Quick estimation, -2.18 should be somewhere here. 4.69 should be somewhere here. So
0.489.
Likewise, 0.48 should be somewhere here. What else is still missing? We have the x-intercept. We also need to have the y-intercept. How to find the y-intercept? Make x is equal to 0. When this 0, 0, 0, 0, what is left? 5. Okay, it's at the midway point. I'm very certain once you have indicated all these points, you just have to join everything together. Yes, Jun Nan.
The second one is 4.689. The third one is 0. So the third one is 0.489.
We need to draw all the shapes out. Of course, you indicate on yours. My numbers are too big. I cannot write it here. After that, you join everything together. Can you see this is a cubic equation now? But I know Andy made a very smart conjunction just now. He said, Mr. Liu, the first one minimum, the second one sure maximum 1. This is true for this question. We're going to move on to a question where it's not true. Okay, and that will be our last question for today.